Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So today we will continue problems on the Fourier transform. So in the last class we discussed about the applications as well as the formulas related to Fourier transform. So today we will solve a problem on Fourier transform. If f of x is equal to 1 minus x square for mod x less than 1 and 0 for mod x greater than or equal to 1, then find the Fourier transform of f of x, and hence find the value of integrals. So we are having two integrals here. The first one is 0 to infinity x cos x minus sin x divided by x cube with respect to x, and the second integral 0 to infinity x into cos x minus sin x divided by x cube with respect to x. Okay, so the function f of x is given and it is defined as 1 minus x square for mod x less than 1 and it is 0 for mod x greater than or equal to 1. Then find the Fourier transform of the given function f of x, and hence find the value of the integral 0 to infinity x cos x minus sin x divided by x cube with respect to x, as well as 0 to infinity integral x cos x minus sin x divided by x cube with respect to x. So obviously we divide this problem into two parts. In the first part we are going to find out the Fourier transform of f of x. Later, by using the Fourier transform of f of x, we are going to evaluate the value of the integrals a and b. So we start with the formula. We have Fourier transform of f of x. So we have a formula here. F of u is equal to integral minus infinity to plus infinity f of x into e raised to iu x with respect to x. So this is the Fourier transformation of a given function f of x. So now in this formula we need to substitute the given function, that is minus infinity to plus infinity. Since the function f of x is splitted into two parts, the first part is obviously 1 minus x square for mod x less than 1, and since we know that mod of x less than 1 means x value is lying between minus 1 and plus 1, and mod x is greater than 1 means x value is lying between 1 to infinity. Okay, it's a simple one. 1 minus x square, the function f of x is defined as 1 minus x square for mod x less than 1 means x lies between minus 1 to plus 1, and mod x is greater than or equal to 1 means x value lies between 1 to infinity. Therefore here instead of putting minus infinity, we will take the limit of first function, that is minus 1, and here it is minus 1, and here it is plus 1. That time the function is 1 minus x square e raised to iu x with respect to x, plus the next limit is obviously mod x greater than or equal to 1 means it implies 1 to infinity. In that case the function is defined as 0 into e raised to iu x with respect to x. and since we know that the second term is 0, so it becomes 0. So remaining is minus 1 to plus 1, 1 minus x square into e raised to I of x with respect to x. So now we need to evaluate this integral between minus 1 and plus 1. So obviously it is a product of two functions u into v. So whenever there is a product of two function, and out of that two function, if one function is a vanishing function, okay, out of there is a product of two function, and out of the product of two function, if one function is a vanishing function, here 1 minus x square is a vanishing function. Why it is vanishing? Because as you differentiate that 1 minus x square, it becomes 0, because the derivative of 1 minus x square is minus 2x, and the derivative of minus 2x is minus 2, and the derivative of minus 2 becomes 0. That's why 1 minus x square we call it as a vanishing function. So if there is a product of two function and one function is a vanishing function, then we will evaluate this integral by using the Bernoulli's rule. What is Bernoulli's rule? Just I will write here. Bernoulli's rule means integration of u into v can be written as u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 and so on. So this formula is called as the Bernoulli's rule, and this Bernoulli's rule we use it whenever there is a product of two function, and out of that product one function must be vanishing. So now here I will take u as 1 minus x square and v as e raised to I of x, and applying this formula, so we are having here u is nothing but I am going to take u as 1 minus x square, and I will take this as v here. So u as it is 1 minus x square into v1. v1 stands for integration of e raised to I of x. So integration of e raised to I of x is e raised to I of x divided by IU minus u dash. U dash means the derivative of 1 minus x square is minus 2x, writing everything in the bracket, and again v2 means integration of this term, this function, okay. So it is e raised to I of x divided by I square u square. Again the third term plus u double dash, that is derivative of minus 2x will be minus 2, and integration of this function will be e raised to iux divided by I cube into u cube. Bracket complete, applying the limits minus 1 to plus 1 here. So simplifying further, so applying the upper limit, or first you simplify this whole thing. So we are having 1 minus x square as it is into e raised to iux divided by I cube. And since we know that I square is minus 1, I square is minus 1, obviously I square is minus 1. So minus into minus become minus 2, it is minus 2x become obviously plus, obviously I square is minus, minus into minus become plus, and since there are 3 minuses here, so it become minus 2x into e raised to iux divided by u square. Similarly here I cube is nothing but I square into I. Since I square is minus 1, so it become minus I. So minus into minus become plus here. So it is 2 into e raised to iux divided by I into u cube, applying the limits minus 1 to plus 1. Now we need to apply the limits, upper limit minus lower limit. So upper limit is 1 and the lower limit is minus 1. So upper limit 1, so wherever x is there, you just substitute x equal to 1. So 1 minus 1 will be 0, 0 into anything is 0. So here it is minus 2 into, so put x equal to 1, the upper limit, and it become e raised to iux divided by u square. Similarly for the last term, put x equal to 1, we have 2 into e raised to iu divided by I into u cube. Now coming to the lower limit, and since we know that while taking the lower limit we need to take a minus sign. So again 1 minus of minus 1 the whole square becomes 0. So 0 into anything will be 0. Now applying the lower term for this second term. So 2 into minus 1 will be minus 2. Minus into minus become plus. And since we know that we are applying the lower limit, so we get one more minus here. So it is 2 into e raised to minus iu divided by u square, and the last term, that is minus 2 into e raised to minus iu divided by I into u. So after this, from the first term and the third term we are having minus 2 by u cube u square, sorry, it is common. From the first and the third term we are having 2 by u square common. So taking it out, and obviously here we have substituted x equal to 1, so it becomes e raised to iu and plus e raised to minus iu. And from the second and fourth term we are having 2 by I into u cube common. So inside the bracket it will be e raised to iu minus of e raised to minus iu. This is equal to minus 2 by u square into bracket, and since we know that e raised to I theta plus e raised to minus I theta, there we get I theta, I sin theta cancel, and we get here 2 times of cos of u. Okay, we have a standard formula, that is e raised to I theta plus e raised to minus I theta will be always 2 cos theta, but here we are having e raised to iu plus e raised to minus iu, that is nothing but 2 times of cos u. In a similar way, it is 2 divided by I into u cube inside the bracket. Again here e raised to iu minus of e raised to minus iu, we can compare this with the standard form again, e raised to I theta minus of e raised to minus I theta. There we get 2i into sine of u. So now I get cancel. So here we have minus 4 into cos u divided by u square plus I get cancelled, 2 2's again, it is 4 times of sin u divided by u cube. Later we can take a LCM here. Obviously LCM will be u cube, that time it become minus 4u into cos u plus 4 sin of u. Taking 4 by u cube as common, we have here, that is minus 4 by u cube, I will take common, so remaining is u into cos u minus of sin of u. So this is the Fourier transform of the given function f of x. So the Fourier transform of f of x is given as minus 4 by u cube into u cos u minus sin u. Okay, so that is nothing but f of u. So this is the first part of the problem. So from the first part of this problem, we have a Fourier transform of the function f of x is f of u equal to minus 4 divided by u cube into u cos u minus sin u. So now from this answer we need to evaluate these two integrals now. And to evaluate these two integrals, we are going to use the inverse Fourier transform formula. So we have a formula that is f of x is equal to 2 divided by, it is 1 divided by 2 pi into integral minus infinity to plus infinity f of u into e raised to minus iux with respect to u. So now substituting f of u in this formula, that is 1 upon 2 pi integral minus infinity to plus infinity, f of u is nothing but 4 divided by u cube into, it is u cos u minus sin u into e raised to minus iux with respect to u. So our intention is to get the value of this integral. But here when we substitute f of u here, and first our work is to reduce this integral into this form. Actually what we do here is, we are not going to evaluate the integral, but just we simplify this integral in such a way that we can bring this integral into this form. And since when we observe this integral, we come to know that there is no exponential function here. But here we are having an exponential function, therefore we need to eliminate this exponential function so that we can reduce this integral into this form. So for that we put x equal to 0. So substituting x equal to 0 in the integral. Since this is f of x, so when we put x equal to 0, it becomes f of 0 is equal to 1 upon 2 pi into, I will take this minus 4 outside, remaining integral is minus infinity to plus infinity u cos u minus sin u divided by u cube. And since we have substituted x equal to 0, so it becomes 1 and the remaining is only du. So simplifying further, 2 to the cancels, we get minus 2 by pi integral minus infinity to plus infinity u into cos u minus sin u divided by u cube with respect to u. And since we know that u cos u minus sin u divided by u cube is a even function. So if it is even function, then we can write the integral as 2 times of, obviously here we are having the limit between minus infinity to plus infinity, and when we come to know that this function is an even function, then by the properties of integral, this limits can be written as 2 times of integral 0 to infinity into, it is u into cos u minus sin u divided by u cube with respect to u. And here we are having f of 0. Then what is the value of f of 0? And since here we are having a function f of x equal to 1 minus x square for mod x less than 1. So mod x less than 1 means x lies between minus 1 and plus 1. Therefore this x equal to 0 lies in this range. So if x equal to 0 lies in this range, then the function value at x equal to 0 will be 1 minus 0. So 1 minus 0 will be 1 here, and I will cross multiply these numbers this side, so it becomes minus pi by 4 is equal to 0 to infinity u into cos u minus sin u divided by u cube with respect to u. And since we need to find the value of this integral and here the variables are x, therefore the last step is replace u as x. Replace u as x. So we get minus pi by 4 is equal to integral 0 to infinity x into cos x minus sin x divided by x cube with respect to x, and that's the value of the integral. So it is equal to minus pi by 4. Okay. Evaluating the second integral now. Once again, we use inverse Fourier transform formula, and since again for evaluating this integral we are going to use the Fourier transforms which we obtained from the first part. So Fourier inverse Fourier transform f of x equal to, it is 1 by 2 pi integral minus infinity to plus infinity f of u into e raised to minus iu x with respect to u. So in this formula, once again substituting this Fourier transform f of u, so we have f of x equal to 1 upon 2 pi integral minus infinity to plus infinity, f of u is nothing but minus 4 by u cube into u into cos u minus of sin u into e raised to minus iu x with respect to x here. And when you observe the integral, actually the mistake agida naditante. Okay, so we need to evaluate this integral. When we observe this integral, we come to know that with x cos x minus sin x divided by x cube, there is cos x by 2. And since in this function we are having e raised to minus iux, it means that we need to replace this e raised to minus iux as cos x by 2. Then how to obtain this cos x by 2 from this e raised to minus iux? So for that we use a substitution x equal to 1 by 2. So when we put x equal to 1 by 2, this f of x become f of 1 by 2 is equal to, means wherever x is there we are going to put 1 by 2. So this become, I will take this minus 4 outside, so it is minus 4 by 2 pi integral minus infinity to plus infinity u into cos u minus sin u divided by u cube into, in place of x we are substituting 1 by 2 and it become e raised to minus I into u by 2 with respect to u here. And since our intention is to get the value of the integral 0 to infinity x cos x minus sin x divided by x cube into cos x by 2, and still there is an exponential function, and this exponential function we need to reduce it in terms of sine and cosine. So therefore I am simplifying further, so it is minus 2 by pi integral minus infinity to plus infinity u into cos u minus sin u divided by u cube, and this e raised to minus u by 2, since we have a property that e raised to I theta can be written as cos theta plus I sin theta. In a similar way, e raised to minus I theta can be written as cos theta minus I sin theta. Therefore, by using this formula, e raised to minus u by 2 can be written as cos of u by 2 minus I sine of u by 2 with respect to u. And since we need only cos x by 2 here, therefore we just take the real part and we ignore the imaginary part, just multiplying real part with this function and imaginary part with this function, and ignoring the imaginary part and taking only the real part, because we need to consider only the real part to evaluate this integral. So we have f of half is equal to minus 2 by pi minus infinity to plus infinity u into cos u minus sin u divided by u cube into cos u by 2 with respect to u, ignoring the imaginary part. And since we need to find out the value of f of half means obviously that half lies in this range only, that is mod of x less than 1. So substituting x equal to half in this function, we have 1 minus half the square will be 1 minus 1 by 4. So 1 minus 1 by 4 will be 3 by 4, and cross multiplying this minus 2 by pi. So we have minus pi by 2 is equal to, remaining is minus infinity to plus infinity u into cos u minus sin u divided by u cube into cos of u by 2 with respect to u. Simplifying here, so we have minus 3 pi by 8 is equal to, and now once again this function is a even function. Whenever the function is even here, then by the properties of integral, we can write the integral minus infinity to plus infinity as 2 times of 0 to infinity u into cos u minus sin u divided by u cube into cos of u by 2 with respect to u. And since our integral is in terms of x, therefore replacing u as x here and taking this to this side, and we have the answer, that is 3 pi by 16, and here replacing u as x. So we have the final integral 0 to infinity x into cos x minus sin x divided by x cube into cos of x by 2 with respect to x, and hence this is the value of the integral x cos x minus sin x divided by x cube into cos x by 2, and hence the proof.